Hello and welcome to this Tech Talk. I'm Rami Asawi and joining me in this session is Ben Farr. Today we are going to talk about Quarkus and how it is enabling Java to become highly relevant in the cloud-native world. And Quarkus is a Kubernetes Java stack tailored for GraalVM and the OpenJDK hotspot. It is crafted from the best-of-breed Java libraries and standards. Don't worry if you didn't understand all of that, because in the coming slides, we're going to go through a bit more of what that means and what the value of Quarkus is. But before we do that, we wanted to start with a bit of history to set in the context to better understand the problem that Quarkus is looking to solve. As you probably already know, the Java language is turning 25 years old this year, and Enterprise Java turned 20 years old this past December 2019. Java and the Java platform have been very successful and have created a multi-billion-dollar market, and there are over 10 million Java developers worldwide working for organizations that run their businesses successfully using Java for their production workloads. Java has become and continues to be the enterprise workhorse. But Java was created in a time where the cloud, containers, and Kubernetes did not exist. Service-oriented architecture and monolith were the development paradigms commonly used back then. Back then, long startup times were dependent on the nature of the application and not a top-of-mind kind of concern, and memory consumption was related to all the on-premise hardware resources. As new development approaches, such as microservices and cloud native, were introduced, Java continued to remain relevant in the market. Many microservices frameworks are based on Java and the JVM, such as Spring Boot, Scala, and Kotlin, which has now become Google's choice for Android. However, moving to more highly distributed architectures like function as a service, boot up time started to become important and even a differentiator across development languages. Compute and memory resource consumption started to be areas of concern to organizations leveraging the cloud for their development efforts. The challenge of Java running on the cloud, containers, and Kubernetes is that it consumes a lot of RAM, and its startup time is slower than other languages, especially if you're trying to run it in a memory-constrained environment to get really high density. Because of the way the JVM works, it was really optimized for large heaps for big bare metal servers, and has made a lot of design choices that gave Java great performance in this sort of environment, but not necessarily that great when running in a small environment like a container. So on startup, there's a lot of overhead when parsing all the classes and compiling them from bytecode into machine code. There's also a lot of memory overhead because Java classes all support reflection. That means that Java needs to kind of sort all of that metadata, including field names, annotations for every class that is ever loaded. In general, Java applications tend to start a bit slower and they tend to use more memory because you have this whole metaspace area that's just full of information about classes. So basically, the more classes you load, the slower your application will start and the more memory it's going to use. So as you can see in this diagram, there is a significant difference in memory usage between a typical Java process and other competing languages, namely Node.js and Go. As you can see, Hotspot has the largest footprint, which includes heap memory allocated per JVM instance. The middle column shows Node.js and how much smaller each process is compared to Java. All the way to the right, you see Golang with the highest deployment density. This is the reason why developers started to shy away from Java, including Spring Boot, when it comes to writing applications on the cloud, containers, and Kubernetes. And this is where Quarkus comes into play. Quarkus is a framework which takes Java to the next level of scale and performance for cloud-native development. There's been already early adopters of the framework, and they all have seen incredible results when it comes to cloud resource consumptions, as testified by this IDC report. Startup time, and for example, Lufthansa, the European airline, could run the same workloads in 1/3 of the infrastructure without sacrificing availability or response time. We're often asked what the name Quarkus means. So the name is actually a combination of two words. Quark, and if you go back to your early high school days, you might remember that quarks are those tiny elements which help make up protons and neutrons. And us. Well, us is the hardest thing in computer science. So Quarkus as a name represents where this new framework taking Java on a supersonic subatomic level. Quarkus makes a lot of optimizations around how a framework actually starts. Normally, when you start a framework, it looks something like this. You build your application with Maven or Gradle. You then load configurations from the file system, so this might be XML descriptors or AMQ configuration, for example. You then scan the class path, find annotated classes, and then load them to figure out which features need to be enabled or disabled. And you then build sort of an internal meta model to figure out exactly which services need to be started, in which way, and basically figure out how the whole application works together. And once that all is done, you can actually start the service. So you can start thread pools, you can open sockets, you can connect to the database, and what have you. Quarkus changes all of this. A good number of those startup steps are actually moved to build time. It does all the scanning and parsing at build time, and as much as possible, it tries to figure out the internal meta model at build time. And then it will write that into an explicit bitcode instruction in the application to tell Quarkus exactly which services need to be started. This has a number of benefits. A big one obviously is that the less work you do at runtime, the faster your startup is going to be. But it also means that all of those classes that you normally load to do all of this processing and that take a whole lot of memory, they just don't need to be loaded during your application runtime. And this is what really differentiates Quarkus from other frameworks. Don't just take our word for it. This report from IDC compares Quarkus with another widely used framework for cloud-native development, referred to in this slide deck as Framework A. 3 application types were compared, namely Quarkus Native, Quarkus JVM, and Framework A. The startup time for Quarkus Native was roughly 12 times faster than Framework A when tested on premises, while Quarkus JVM was twice as fast compared to Framework A. When running in serverless mode, the median startup time was 4.5 times and twice as fast for Quarkus Native and Quarkus JVM respectively. And when it came to memory usage, Quarkus Native reduced memory usage by 90% in comparison to Framework A when tested on premise, while Quarkus JVM was less by 20%. Testing the same application while running on OpenShift on AWS, the memory usage was 1/8 and 2/3 for Quarkus Native and Quarkus JVM respectively. Obviously, because you can deploy more applications giving the same amount of memory, the number of pods that could be started using Quarkus exceeded that of Framework A by 8 times for Quarkus Native and 1.5 times for Quarkus JVM. Quarkus improves developer efficiency by reducing the number of operational steps required to update applications. By unifying both imperative and reactive programming models, Quarkus gives developers the freedom to choose the style of programming. Quarkus reduces maintenance time. The use of Quarkus led to cost saving driven by the higher deployment density and the reduced memory utilization. So an expenditure of $100,000 annually in memory consumption for Framework A on AWS roughly translates to $63,000 with Quarkus JVM and only $36,000 with Quarkus Native. Based on reduced memory utilization, Quarkus JVM and Quarkus Native deliver cost savings as of 37% and 64% respectively. And if you still have doubts, Ben Farr is going to demonstrate those benefits right now with a couple of cool demos. Over to you, Ben.
So let's have a look at the benefits of Quarkus. The first cloud-native challenge we really need to achieve with Java is the startup speed. And let's have a look at a demo of how Quarkus addresses that, or what are the results. So here I've got two projects, a Quarkus Hello World and a Spring Boot Hello World. Simply just returning the name that I enter as a parameter, and that would be seen in a HTTP call. As you can see, the code is of similar basis. Quarkus is using the JavaX libraries. And what I'm really going to do is have a race in between all three different variants. I'm going to have Spring Boot compile with my Java. I'm going to have Quarkus Native and Quarkus JVM. So I've logged in now to my AWS account. I'm simply all going to run these in an AWS VM. So if I go into my script, I've got a script which fires up all the Spring Boot Hello World and Quarkus Hello World, both the native and the JVM version. So as you can see, 3 lines there, and it's firing Java, Spring Boot, Java Quarkus, and the native runner, which obviously you don't need the JVM. And what I'm doing here is got a load meter test of JMeter that's running in the background. I start my fire up script and we see who responds first. So you can see in Quarkus Native 21 milliseconds it started. In my Quarkus JVM version, 3.379 seconds. And with my Spring, I've done it in 6.9 seconds. So I'm now looking at the time to first response. So in my Hello World of Spring Boot, the first response you'll see really on line 3 at 12:01:51. And now look at my Quarkus JVM. It returned at 12:01:45 the first response, so 5-6 seconds earlier than the Spring Boot Hello World. And with my Quarkus Native, it returned at 12:01:42. So not only are we talking about faster startup, we're talking about really faster time to first response. So now, it's all well and good to have a simple REST application, fairly simple scenario use case there. Really want to test now is how it works with a database backend. And what I'm doing here is a MongoDB backend. So I'm firing up my MongoDB container, and in turn I'm going to fire up each application in turn in Spring Boot, in Quarkus JVM and Quarkus Native. So I've got my Spring, it started in 7.5 seconds because it had to establish a data source and everything like that, so there is a bit of startup involved here. So if I try my Quarkus now, so now I'm going to try the Java version. And you can see you still run it as a java-jar. It is Quarkus simply does just produce a jar as normal. And with Quarkus, rather than the 7.5 seconds, it's 2 seconds startup. And that's also establishing the data source in the background as well. And with my native image, you'll see that in the runner version there. It was cut off there, but the table here summarizes what we saw in the demo. You've got the startup times in our demo on the right here, the REST Hello World and the REST MongoDB. And in the first column here, we've got the typical time to first response, which we've seen as we've been developing Quarkus. Now, in a tested environment on larger machines than my T3 Medium, I would expect to see the startup times for REST and REST plus CRUD with database and significant savings in both the JVM and the native modes. And what Quarkus is doing, it's optimizing those frameworks to make them more modular, and it reduces the dependency to achieve this startup speed. So let's have a look at the second cloud native challenge, and that is to shrink resources. So again, here I'm using the same applications as I used in the first demo. It's simply hello worlds with your 3 different flavors. What I'm going to do here is examine what we call the resident set size memory, or the non-swapped physical memory. That is the memory that's currently in use in the machine. And you can achieve that by looking at using the ps command and looking in the third column for RSS. So I'm going to fire them all up. And then we've got my Quarkus Native, my Spring Boot, and my Quarkus JVM. Now I'm going to look at the resident set size, and for my Spring Boot Hello World, I've got 700 meg simply just used by startup, 282 meg for the Quarkus JVM, and 23 meg for the Quarkus native version. But what if I apply some load, and how would it react then? Would it be comparatively the same? So I've got my JMeter test in the background, and again I'm firing against all three, and I'll start to sort of now take, a quick sample measurements and see what's happening. So I've got a 711 meg for the Spring Boot Hello World, again 363 meg for the Quarkus JVM mode, and 44 meg for the Quarkus native. And again, third time, similar results as the load test here is running in the background. So I'll stop that now and have a look at the throughput. And what we see is the throughput hasn't been sacrificed. The average return time in milliseconds of what's been returned on all three is the same. And what we have found in the Lab IDC study is that the Quarkus JVM mode would have typically the highest throughput for your particular use case. So now I'm going to sort of run with JMX and log in, and just to give you a view of what's happening underneath within the JVM layer. So here I've got, I want to see sort of the number of classes loaded, and compared to Spring Boot, which had 7,226 classes loaded on startup, I've got 4,775 in Quarkus. So you can start to see why the startup time's quicker, why is memory reduced. The number of classes loaded has been optimized and reduced. In terms of threads, there's a few more threads in Quarkus due to some event bus threads that are happening in the background, which you can make use of. And if you look at here at the heap memory usage, you can see Quarkus on the right has significantly halved, 22 meg compared to sort of 49 meg on startup. So Quarkus does reduce memory utilization. The results from our demo in the resident set size, or RSS, we can see Spring Boot with about 680 megabytes in our REST Hello World, 666 megabytes in the REST and MongoDB. If we look at Quarkus with the OpenJDK on the back end, we've got 223 meg for a simple REST Hello and 337 meg with the database back end. So you can see easily halved from Spring Boot. With Quarkus Native, we get down to even lower levels there, again with 23 megabyte and 40 megabyte in memory utilization for the same result. So typically we've seen these results as we've been developing Quarkus, and you can see the results there on the left with the REST and the REST plus CRUD. So Quarkus optimizes these frameworks to make them more modular, and it reduces the dependencies to achieve this both the startup time and the memory utilization. So how can I get started with Quarkus? So launch.openshift.io gives you an access to a series of templates, and Quarkus being one of them. So I'm going to simply now choose to create a new application, and I'm going to, in this case, configure a backend. It could be a front end, it could be a web application. And I'm going to choose a runtime of Quarkus, and I'm going to give it some capabilities sort of out of the box, so I've got some template code to go on. After that, I'll be able to download that as a zip file. Once I've got that zip file, simply unzip it, and I've got my Java Maven project all set up to import. If I go to the terminal and launch you can use any IDE of your choice, but in this case I'm using VS Code. Once I import my project, you'll see here I've got a source main Java. I've got a couple of classes in there with a greeting endpoint, and this is all came out of the box as a template. So let me now do sort of a nbn clean package, and that will simply sort of start to compile. It will download any jars that you may not have in the desktop, so it may take a little while for you in the beginning. But after that, I'm into my nbn Quarkus dev mode, and what this gives me is the ability to do live coding. Again, you see really fast startup for this in 1.2 seconds. If I go to my local host, which is running on port 8080 now, and go to my app, I can see that my application is running. So now let me return to the IDE, And I'm now going to, again, it's just a greeting bean. So let me try and change the greeting endpoint and insert sort of a, hello Ben, how are you? Or if I save that, if now I can see nothing in the Quarkus at the moment, but as soon as I start to hit that request again, I'm going to see that code changed as I saved it. What it's done is a hot replace, and you can see within your console, you'll see that you'll see that hot replace within the logs there. So now let me try and show you another example. And this time I'll sort of start to deliberately make some errors, and you'll see sort of the error messages that you get, a developer would get as they're developing with Quarkus. So I'm going to add another path with, say, another greeting. And let me refresh that. Other greeting. At the moment it's a 404. I didn't actually save it, so it wasn't affected. And now I've actually got a compilation error. But you do see the result in Quarkus. It's not like a 500 error code that you would see in the return, simply because I had a duplicate method name. I'll fix that now and save it, and then start to refresh it. Again, presto, it works. You're not simply don't have to save your file and testing it as you go. Great for building your new applications. So you've seen a little glimpse of the developer joy we're talking about with Quarkus. Quarkus is a lot more than a runtime. It's a stack of technologies. It provides a low learning curve. It's a standards-based framework. Provides those meaningful error messages that you saw in the demo. The live coding, which is a lower troubleshooting, lower cycle time of developers, and provides really no hassle native executable generation. But it also has a best of breed frameworks and standards. So we have 90 plus extensions, which allows for sort of both paradigms of imperative and reactive programming. You can get your Kubernetes based APIs, your Jaeger open tracing, your Apache Kafka, MQTT processing, REST Easy, and Apache Camel. Are some of the key ones that we focus on, as well as your databases like your MongoDBs and other JDBC connections. So let's look at the tail of production. Well, Vodafone Greece runs many applications on-premise and in cloud, and they had a UX layer written in Spring Boot. But they were concerned with cloud costs, they were concerned with startup performance for their user experience, and they were concerned with, if they did change to another language, how would they reskill their developers? What would the time and cost be? So they searched the market for other technologies and frameworks, and they sort of looked at natively compilable frameworks. They looked at Node.js and they looked at Vertex. They decided that Node.js would not be a good option for them because the burden that would put on their Java developers to learn and migrate Java applications. However, since using Quarkus, Vodafone Greece has seen sort of memory halved, from 1 gig to 512 megabyte for services. Startup times have been reduced to almost a quarter without any optimization, and with many of them connecting to Kafka and databases, they're usually expensive operations. And with Quarkus, they saw a 30 to 40% better developer productivity, and this is from an ex-Spring Boot developer. So some key takeaways. Quarkus is a new technology aimed at cloud development. Number one, you don't need to relearn new APIs. Number two, it reduces your cost. Look at that lower memory consumption. The IDC report will expand on how you can save costs in the cloud there. Number three, fast startup time, perfect for cloud and Kubernetes environments. And number four, Quarkus is production ready. A really new quote from Twitter shows that we've really hit the sweet spot. It feels familiar and new at the same time. So after this webinar, how do I get started? So there's learning links, interactive tutorials and quick starts available. And when you're ready to dive deeper, recommend really the Quarkus.io website. It's full of blogs, guides, and a community there who is really eager and keen to collaborate and engage. So if you haven't seen enough today, join us for our Quarkus hands-on workshops. This will basically get you hands-on with Quarkus, deploying in containers on OpenShift, and it'll cover from the basic demo all the way up to using JPA and open tracing as well. Thank you very much.